Yeah, welcome to FMX, first day of this year's edition, 2024, Connecting Ideas. And this is the Technical Directing and the Set Extension Workshop presentations. We'll start with the technical directors. Technical directors, they glue the technical and the creative components of our Filmakademie projects together. They engage in their own research projects. And today you'll see two presentations from our second-year projects, or second-year students. So we have Vincent Maurer and Sturm, and then we'll have a special presentation from Golter on his research project, the Acid Cooker. He already received his final degree. After that, we'll take a look at the set extension workshop and some in-camera visual effects. And without further ado, welcome Hannes.
Hello everyone, I'm Hannes Sturm, technical directing student in my second year at the Animationsinstitut of the Filmakademie. My journey as a TD student started after finishing my bachelor's degree in media computer science at the University of Tübingen, focusing on human-computer interaction and machine learning. Right now, my focus lies in AI tools and real-time technologies. Let's take a peek at the projects I've been working on in the past few months. They range from Unreal and Unity games such as Cosmos and Miasma to 2D and 3D animation short films such as Sensual and Aspera Song. But let's take a deeper look at the deep above. Exactly 1 year ago, I started working on the project The Deep Above, a third-person Unreal game. It was my first time being the leading TD of a larger student production, and I was responsible for the animation system as well. At the time, motion synthesis had my attention, so I set out to create a motion matching system for the game and aiming to integrate a learned motion matching system as well afterwards. Learned motion matching is a query-based animation pose selection system, and what it basically does, it takes this complex state graph and reduces it to a single node, which represents an algorithm which plays the right animation and pose at the given time. This was our vision. You can see smooth transitions between animations, making the character feel more dynamic and lifelike. For this demo, I used AI-generated animation generated by Motorica AI. But we didn't want off-the-shelf AI-generated animations for our project. We wanted to have our own style. So we captured our own mocap data. For this, we took those motion patterns called dance cards, where the actress had the task to follow those patterns to capture a large set of different walking situations. Here you can see some impressions from the shoot. As you can see, we have marked the patterns on the floor with differently colored tapes and also highlighted the current dance card with additional cones, so it is easier for the actress to follow the path. After we captured the data, we went into post-processing and retargeted the animation, did some cleanup, and also I wrote a script to fix the root bone to make it planted between the feet of the character instead of at the world's origin. The script also took care of exporting the files in the right format for the Unreal Engine. Inside of Unreal, we created an animation database, which you can see on the left, and on the right you can see the final result. As for the learned motion matching system, which is basically like motion matching but using AI instead of an algorithm, it proved to be a beast of its own. It didn't work out in the end as expected, but on the way I learned a lot about AI, about animation, rigging, and so on. And the training phase is already working, but the generation of animations, didn't work out in the end, as you can see right now. It's not quite there yet, but I think we can improve this in the future with a bit more time. Coming to the next project, Sensual. An ongoing project, and the director sought a method to bridge hand-drawn animation frames with in-between frames. Seizing the opportunity to use 2D AI for this, I jumped right in. Here you can see our director painting every third frame of an animation by hand with watercolors. And after scanning and stitching together those frames, you have this animation, and my task was to make it look smoother. There were plenty of challenges. First of all, the details and highlights of the lips are not very consistent over the frames, which makes it really hard to create in-betweens. Also, the style of the images has to match exactly the one of our director, and the overall animation style should also follow the vision of the director. It should flicker a bit to give the illusion of hand-drawn frames, but also not too much to make it look like it's AI generated. This was one of our first tests using stable diffusion extensions, but we quickly found out that we have to balance between smooth motion versus details. As you can see here, the lips are very blurry. A few iterations later, and after a few tools we tried out, we came across Topaz Labs, which is a standalone tool which can increase the frame rate of videos, and initially it yielded results with slight blurring, but we could fix that with further refinement with Absinthe. Also a standalone tool which is used for texture transfer, enabling seamless application of textures from one image to the other while preserving their respective structures. And you can see again the result. And I'm sure and optimistic that we can improve this result in the next weeks further. Last but not least, let's talk about research. In every TT student's journey, there has to be a research project in the second year, and mine centers on masked real-time style transfer for Unreal Engine 5. Picture this: a neural network rendering specific scene objects in a model-specific style, art-directable and animatable from inside of Unreal, but also from other softwares like Maya. What was the motivation? Injecting AI into real-time renderers, empowering art direction, and enabling custom animatable styles. And it was also a key ingredient for my diploma project, it still is, Kitsune, where our fox character demands an AI-inspired aesthetic. And since this diploma project is a cross-media project consisting of a film and a game, which will both be rendered inside of Unreal Engine, it made sense to integrate this style transfer tool inside of Unreal to have a consistent look over both formats. How does it work? Basically, we take the rendered image of the fox character, for example, push it through a neural network using Onyx Runtime, which is a framework for running neural networks in real time, and then applying it in the final stage as a post-processing effect on the final image using the stencil buffer as a mask. This was our first test, using some model for the style test running inside of the latest Unreal version. As you can see, there are some improvements to make. So looking into the future months, we've got our sights set on implementing the masking and also enhancing the performance. Plus, we are planning to increase the resolution, fine-tune the controllability, and also integrate the whole animation pipeline. But that's it for now. Thank you for listening. Feel free to contact me if any of those topics got your interest to talk about them in more details. And I hand over to Vincent.
Hi, my name is Vincent Maurer, and I'm a technical director at Filmakademie. I'm going to talk about in-camera VFX, pipeline lighting and compositing on my diploma project, and about my research on lens capturing. First about me, I'm a virtual production TD, and I focus mainly on virtual production and also on lighting and compositing for CG. I study animation, and I specialize in technical directing. I've worked as a 3D journalist and freelancer before, and specified more and more into virtual production and lighting and comp. During my mobility year, I've worked as a virtual production TD at ILM on Percy Jackson, and as a lighting artist at Sony Pictures Imageworks on Spider-Man Across the Spider-Verse, which was quite a nice mobility year, I've got to say. Getting into my previous projects, I've mainly worked on real-time render projects like Tamsterbacke and Mnemonic, some VFX projects like Drain Spotting, and virtual productions like The Last Smoker and High Score Heaven, which was my set extension workshop. I also joined the set extension workshop this year, which you're going to see later. But I'm quickly going to talk about what I did on that. Here's some images from that workshop. We basically used an LED screen to virtually extend our set. And my task as a virtual production 2D is building the tools that allow the artists on set and the director and camera people to make the most out of the LED stage. So yeah, let's talk about what I did there. First, I set up the configuration for the end display LED stage in Unreal. So we built like a projection setup in Unreal that projects the camera view on the LED screen. And I also built some onset tools so we could measure out the set with this wand here and get like a lot of dots basically on our set so we could see which objects are at what point on the set, since we had a lot of modular elements that had to align with the virtual world. We also had a 360 rotating shot, but as you can see, there's only a wall. So we rotated the actor in front of the camera and tracked the world to the actor instead of rotating the camera around it. And I also built some on-set UI tools for a tablet where we could control the color grading and like position of the stage on set on a tablet in front of the stage. Yeah, getting into other stuff. I'm currently working on my diploma project called A Sparrow's Song. This is a 3D animated short, about 7 minutes long, 80 shots, which is quite a lot. So we had to do some work in terms of pipeline. With the help of Paul, we set up the shot grid and flow integration for our DCCs like Maya. I built a custom external syncing workflow since all our external animators had to get synchronized to our files on our local share, and also wrote some custom publishing scripts so we could get out our data to our animators. I also built some custom Playblast tools. It's very small here, but we basically get the state from ShotGrid for each shot, so we could see it in the final edit and see like where we are in terms of progression. We're done animating now and focusing more onto lighting, which is more my topic. We are the first Filmakademie project since 2018 that uses Katana as their rendering tool. So I built a custom Katana lighting template that basically gets all our shot data in and has multi-shot lighting, so we can light multiple shots at once since we've got lots of same-as shots and render them out together. We also set up the asset workflow in Arnold, also in Katana, where we basically get all textures for the assets and automatically generate like a very first version for our shading so we can work faster. And here you can see some shaded results of our characters. Yeah. And after lighting, there's also compositing, which I also enjoy doing. So I'm currently building up our comp template, which gets in all the render layers and render passes and merges them all together. We built some custom realistic grain setup that is particle-based for Nuke, since we have to have like a very gritty filmic World War II look. And also set up some different tools like our eye-ping setup, which basically allows the compositor to place the eye-ping later in comp, since all our eyes are mainly hidden behind masks, which is kind of difficult to light. Getting further into our research, which is also part of my diploma, my research is on the topic of capturing lens flares. And I was approached by the director of The Deep Above, how can we recreate this lens flare? And as you can see, this lens flare, it's quite magical. It has like nice streaks down there because it's anamorphic, and like those rainbow artifacts here and more rainbows here, and those are quite hard to recreate in compositing, since all the lens flare tools that exist mainly use either like 2D animated sprites or do simulations, but they don't get all the intricate details that an actual lens flare from the real lens has. So I was tasked with the research on that, and I looked around a lot. At some point I was like, maybe robots are the solution for it, but let's get back a little. What even is a lens flare? Lens flares consist of a couple of different parts. So lens flares are basically all the type of light that don't get to the sensor directly. So some of the light gets reflected on the boundary between air and glass and gets bounced back on the sensor. As you can see here, those are those like donut shapes and circles. They're called double reflexes. There's also something called forward scattering, which is basically some of the surface of the lens isn't quite smooth and is a little bit rough and scatters the light like that here. And there's also internal reflections, so like parts of the lens light reflect against the housing of the lens and are shown here as like those rainbows. And those are quite hard to recreate. Currently there's two different types of approaches. You either move around 2D sprites, Or you use simulation, but those simulations are a little bit too perfect sometimes, and they don't capture all the intricate details of a lens and all the coatings, because those coatings are quite complicated. Or you can rotoscope it from existing footage, which is also not ideal. So I thought about, like, what can we do better? Or like, what's a different way to get those lens flares? And I looked into capturing light fields, which is basically you take an array of cameras and you are able to get the lighting information from the scene. So what I'm thinking of, like, okay, can we take a screen or like an array of lights and put that in front of our cameras and turn them on like one frame after each other and generate a grid of lens flares like here. I tested that with some different screens and LED screens, and this has proven to be a little bit difficult since those screens are not quite bright enough and you get a lot of issues with like incident light. So I thought about, can we turn it around? So I take one light source and rotate the camera. This is what I'm doing, and yeah, I did a first prototype for that. So I basically took a camera, put it on a nodal head, like an automatic panorama head, and here's the results from that. So we've got interactive lens flares in Nuke, and I'm just interpolating between them. It's very low res, like there's not a lot of spatial resolution, it flickers a lot, but the first tests proved to be quite good, and I also already used them on a production, as you can see here in the shot. And it has a benefit of getting actual lens data from an actual lens, and you get the flare and like all the details that come from that. And I've also got control over the aperture, since I'm actually capturing multiple different apertures for each lens. Yeah, so that was quite nice, and I was like, okay, how can we improve that? And this is where robots come into play. I talked to Double Cheese Film, which is a motion control studio in Stuttgart that also held talks at Filmakademie, and they have got a motion control robot like this one here. And they use Mimic for Maya, which is a plugin that generates those paths, to control that robot. So I wrote a script for Maya that basically creates a grid of images, so the camera like rotates for each layer, and you get a grid like that at the end, which is like basically one image per position for the camera. You can see here there's a little bit of weird distortion. I fixed that later. It has something to do with math and spherical projections. You can talk to me about it later if you want. It was a week of work. Yeah, and then like a couple of weeks ago, we went back to the studio and actually managed to capture our data, as you can see here. Wait a second, maybe it plays here. We put the camera on the robot, and it rotated like layer by layer, and here you can see the moving flare. And it created a data set of about, I think, like 3 terabytes, about 1 million frames of lens flares that I've got now, and I've got to think what I'm going to do with it. And I already had some thoughts on what I'm going to do with it. So, like, what are my next steps? What do I actually want to get out of the data set? I've got a couple of different approaches I'm proposing, and I'm currently figuring out which one to use. I definitely want to use Nuke, which is a compositing tool to get those lens flares. And my first idea was, okay, can we just like pick from the data set, like take a position and pick the right frame, and then interpolate between those images? This is the test you can see down here. This is quite nice, but you have to like have a lot of data, and you also need to interpolate, which is kind of heavy on the GPU and CPU. So my second thought was, okay, there's machine learning. Maybe we can train a neural network on those flares. So I trained the convolutional neural network in PyTorch, and the results you can see here. It's a little tough to see, but those flares are generated in basically real time. So I can move the flare around, and it basically picks and interpolates from that data set, also allowing you to blend between different apertures. And my third approach, which I came up a couple of weeks ago, thanks to Benjamin Volker, who is from Zeiss, who does lens simulation there, is basically building a glow from my lenses, from my lens flares. So I'm multiplying each pixel by each lens flare for each individual pixel and adding them all up. And this is where you can get like a nice glow from that flare. Yeah, and you can see here, I tested it here, you get like nice reflections and like perfect glow basically for free from those lenses. Yeah, this is my research. Here's one shot from the deep above that actually used my tool, and you can come up with like some very pretty lens flares. Yeah, that's it from my side. You can contact me here or on LinkedIn or talk to me after the presentations, and I'm heading over to Paul now.
Okay, hello everyone. My name is Paul Golter, and today I'm going to give you a short presentation about my scientific research project, which is called the Asset Cooker Framework. So before we start, some quick words about me. I am Paul. I originally started out as a 3D generalist, and somewhere in 2019, through a coincidence really, I thought it would be a cool idea to be a pipeline TD for a project. And it was love at first sight, and I haven't done anything else since then. I really enjoy developing pipelines, creating tools, and lots of buttons to make artists happy. And yeah, a couple of weeks ago, I did my diploma here at Filmakademie as a technical director, and I will start full-time at Woodblock in May, after FMX, actually. Yeah, and as part of the technical director course, we have to implement a scientific research project for which we have to pitch different ideas, and then we implement one in the course over 2 semesters. So let's start with a short introduction about my topic, the Asset Cooker Framework. Okay, so the core idea of the Asset Cooker is based on a Filmakademie R&D project, the Source project, and comes actually from the following problem. In a pipeline, encoding and transforming data is a very integral process. Let's think, for example, about an asset library. Assets are usually stored in a single format to save data, but the format that is being stored is not always the format that an artist actually needs. And the Asset Cooker should be essentially a lightweight engine that can be used to transform those assets into the required format. But during the development of this project, it became apparent that the Asset Cooker actually has a much broader use case. If I would have to describe this project in one sentence, I would say it is a framework that provides a streamlined solution to create recipes that can convert certain inputs or ingredients to some product. And in more detail, the framework facilitates these 3 major aspects: the collection of recipes that can be defined in arbitrary places, parsing which recipes can be cooked based on some input ingredients, and compiling recipes to jobs that can be executed with different settings. A recipe can be ultimately very simple, for example, converting an Alembic file to a USD file, but it can also get quite complex. And this is what a recipe actually looks like under the hood. They are all implemented in Python, which gives you virtually endless possibilities of what you can do. Currently, there are 3 ways to interact with this framework: from Python directly, from a command line interface, or a web interface. All right, and here you can see a little video of the web interface, and I think it's a great way to understand what the framework can actually do from start to finish. So, the first step is collecting ingredients. You simply put a path in this input field, and the Asset Cooker will collect them as ingredients. Every time a new ingredient is added, the framework shows a list of recipes here that can be run with those input ingredients. From a recipe, you can actually create a job, and all the jobs are listed over here in the cooking view. And a recipe can define settings which are exposed in the job tab and can be modified directly from the web interface. And yeah, the last step is essentially to cook the recipe, and you have this little status indicator from the back end that will supply you live updates of what's happening. And yeah, and the whole point of this framework is that users can actually create their own recipes. And the core part for this is this recipe class. This is a Python class, and users simply need to re-implement it and re-implement the required methods, and they already have a valid recipe that can be essentially collected by the framework. And here you can see an overview of what functions a recipe can have, and when a recipe is getting collected or cooked by the framework essentially calls these methods depending what information it needs from the recipe. And here you can do things like check if the current environment is suitable for the recipe, provide information about what ingredients the recipe exactly expects, define recipe settings and output path, and all these kind of things. All right, a little bit of code, don't be afraid. Running the framework from Python is actually quite straightforward. So you have this recipe collector class here in line 10, which is responsible for collecting the recipes. Recipes can be stored in standard Python modules across various directories, and with an environment variable, you can essentially tell the framework where to look for them. The recipe parser filters recipes based on input ingredients. It resolves all the ingredient requirements for each recipe and returns only those where all the requirements are met. And the parser returns so-called cookables. And a cookable is simply a recipe paired with the matching input ingredients. A cookable can be then compiled to a job, and a job stores extra attributes like the status you've seen earlier in the web interface or a job ID. And for each job, you can then also set different recipe settings. And then as a last step, you cook the jobs with the cooker. All right, and currently the framework already ships with some built-in recipes. We have geometry conversion recipes that can transform any major geometry format to another target geometry format. We have the reduce polygon recipes that can convert geometry files to a poly-reduced version, and the amount of polygons to keep can be controlled via a settings parameter. And finally, we have the sequence to video recipe that can detect an image sequence and convert it to an MP4. Overall, the framework was designed to be pipeline friendly, so those different components all have a kind of a logic separation, and they're all JSON serializable. And that way you can actually plug your own custom user interfaces on top of this framework. So recipes can be run over and over again on changing input data, and of course, while transforming and encoding data is an obvious use case, the possibilities are really endless. So ultimately, you can say the asset cooker gives you the power to encapsulate workflows in a standardized structure. I'm currently also working to open sourcing this framework, so if anyone is interested, make sure to check my accounts in the next couple of weeks. And yeah, thanks for your attention, and set extension workshop is next.
Wo liegt denn die Volker? Volker? Ich komme.
All right, there we go. Welcome everyone to our presentation of this year's set extension workshop. Some of you may already have an idea from Vincent's presentation what the set extension workshop is about, but still I will give you just a brief explanation so you know what we're talking about. So the set extension workshop is a workshop where students of the camera department, the production design department, and the visual effects department work together and learn about the topic of set extensions. In recent years, with a very heavy focus on virtual production, but it also includes the traditional way with green or blue screen. Here you can see our core visual effects team, and for this year, like I said, we work together with production design department and camera department from the 4th year of the Filmakademie. And yeah, we have a lot to cover, so let's dive right into the pre-production. Like always, when you work with virtual production, you have quite an extensive phase of pre-production. In our case, we had about roughly 2 months to create all the CG environments and assets that had to be finished and done for the shoot. The workshop itself mainly focuses on the technical aspects of working with virtual production. But we knew that we didn't want to produce only disconnected individual shots that may look cool. So our director came up with a small story, which is about 2 kids that imagine themselves being secret agents who chase themselves across a futuristic, surreal rooftop in order to escape their boring day-to-day life in their boring real world. So, as visual effects guys, we knew we had to create both worlds. So we started concepting very early on. And together with our production design department, we came up with an overarching style of brutalist slash surreal architecture, which would tie both of these worlds together. Then we created key visuals, basically to keep a consistent look and feel, and also to keep everyone on the same page about what we wanted to create. What you can see here is the key visual for the real world. And here we have the key visual for our dream world. This is basically a dystopian-like extension of the real world and reflects the kind of crazy imagination of the kids. We knew that the set that we would have in mind would never possibly fit into the studio we had available, because in real life the set would have been around 100 meters in length, so no way. So the idea was to split the set into different modules and shoot the different modules. And what you can see here is a plan of how we split the set, and we also included already the position of the LED wall to make the best of our planning.
Yes, so now that the art part and look and feel we wanted for our world was defined, we thought a bit, or had to think about the technical parts. And one important part of in-camera effects is the camera tracking in order to reproduce the correct frame on the LED wall. And for that we built a tool in Blender that allowed us to check in real time whether the camera positions we had in mind would actually be possible. So it would perform a simple raycast, keeping in mind the positions of the practically built elements in a studio, the FOV of the tracking cameras, and yeah, everything that would play a role regarding the tracking, and it would ensure that everything we had planned is actually possible in the set and with our camera setup. We also created quite an extensive pre- and tech quiz. This was quite essential to keep everybody on the same page, make planning shots regarding timing and similar things very easier, and make sure that the vision in all departments is the same and we know what we are actually planning to shoot. This also included checks to see whether the camera frustum would actually fit on the LED wall, since, as Vincent already mentioned, we only had a smaller-ish wall. This was quite vital to keep in mind. Next slide. In addition, or in parallel to creating creating tech viz previs, we also started producing the assets which would be needed for our world to populate it, and we relied quite heavily on cross-polarized photogrammetry. This would speed up our workflow. Here are some examples of the assets we scanned. Some are also hand-built. This sped up the workflow, since the assets that were already built in real life by the production design department could simply be taken over into the digital set. This also made the digital assets way more realistic and ensured that the digital world and real world would match way closer on set and in camera, so to increase realism and detail. But this unfortunately we couldn't build every asset by hand, since there were just too many, since we decided to build 2 cities basically. So we also built some procedural tools. As you can see, a building generator which created many different variations of a building based on a tileable systems. The tiles were modeled by hand, and then the system Philipp built in Houdini took care of basically creating the buildings. This allowed us to get quite a lot of variety, but also was somewhat limited in detail. And also we created a neon sign generator, since it is quite vital to the look we wanted to generate or to have, and we had a custom font created, which then could be plugged into Houdini to generate those signs. And yeah, as said, some assets still had to be classically modeled by hand, since the buildings weren't too high in detail and only acted as background assets. So we also created some hero buildings which were classically modeled by and textured by hand. mainly as foreground elements. And yes, another vital part was the transition between both worlds. We wanted to tell the story of the children imagining themselves being in a cyberpunk world while actually being in the real world, and the moment where this is supposed to become obvious, the futuristic cyberpunk world collapses into the real world. It was quite a difficult challenge, and we pushed back the decision on how to do it quite a bit, but in the end, mainly due to performance constraints, we decided on a shader-based solution in Unreal Engine and use opacity, mask, and vertex displacement, and I think in the end, it looked quite decent, especially considering the time. And while we're on the topic of the optimization, we also obviously took a lot of different other optimizations, such as optimizing topology and triangle count of the assets, reducing the textures as best as possible in size and in texture count, so packing textures. We also used 4 cards instead of volumetrics because they were just performance heavy. And one thing we couldn't unfortunately optimize quite as heavy is the lighting, because of the nature of the transition, we have a lighting change from night to day, and so we unfortunately couldn't bake the lighting and relied on Unreal's Lumen global illumination technology, but this still took quite a heavy performance cost. Yeah, so unfortunately, we sometimes didn't have the best frame rates on the wall, but it was the best decision we could come up with.
All right, so let's get to the actual production. In our case, we had 2 days prior to the actual shoot for testing and doing some last-minute adjustments. Then we had 2 actual shooting days and half a day without the LED wall. For the work on set, we split the VFX team into different roles, and we had 2 people as stage operators and 1 person always keeping an eye on the motive system, so making sure the tracking works and camera data is persistent. One very crucial role we had to fill was the role of the VP soup. This role is mainly focused and responsible for the communication between the departments. In our case, it was mainly the communication between the stage operators and the camera department and the director. But we also had a classical visual effects supervisor who was responsible for collecting data on set, which we could then use in post. And we also had, like mentioned earlier, some classical set extensions using a blue screen. Yeah, the set extension workshop has a main focus on virtual production, and since we had the opportunity to use the LED wall, we thought, why not push it to the limits and test as much as we could. This is one of the most, if not the trickiest shot we had. It is the transition shot where the dream world collapses into the real world, and there were several aspects that made the shot very difficult. On one side, we had the camera should do a circular motion around the actors while the world collapses in real time. We also have a light change that affects the virtual set as well as the real set. And next to that, the actors turn into kids in this shot. So a lot to handle. And we knew that with our confined space in the studio, the circling camera motion wouldn't be possible. So we built this turntable, basically, where the actors could step on, and then we would turn this turntable, and on the turntable itself, there were trackers that were captured by the OptiTrack system, and the rotation of the turntable would then translate into Unreal. So basically, everything except the physical camera spins in this shot.
And as Vincent already said earlier, his tools were quite important and helpful on set, so thank you for that. Yeah, now coming to post-production, I'd say common misconception about virtual production in camera effects is that there is not much post-production, but unfortunately that's not too true, because there are often quite some mistakes that, or due to time constraints or similar things, so that the in-camera stuff doesn't look as great as one would have hoped for. So now it was up to us to fix and improve things that unfortunately didn't work out quite as nicely. In the end, we basically worked on every shot in post-production. There were some exceptions, but most of them were somehow altered, mostly in compositing. We start off the post-production with a shot which unfortunately didn't work out as greatly as you can probably see. There's no grading done, so maybe that can fix some of the issues. But yeah, this unfortunately is not one of the better shots, and if we would have had the time in post-production, which we didn't, we probably would have cut out the foreground elements in the actors and needed to replace the whole background. As said, we didn't have time, so we couldn't do it, and we're still hoping for grading, which is not quite finished, to maybe improve it a little bit. On the other hand, there were some shots which worked out better in our opinion, like this one, for example. We tried to analyze a bit afterwards what aspects help to sell the illusion and what aspects break the illusion, as in the shot beforehand. And some of the aspects we came up with are the mid-ground elements, repeating elements from the foreground to the background, which can also be achieved, for example, with the scanned assets. So you have the same asset in the foreground, which is real, and then the same in the virtual world in the background. And obviously, color and lighting being as similar as possible from the on-set lighting and the virtual one, which also worked out better in this shot compared to the previous one. Another thing, which is why we touched most shots in comp, is because we decided that we don't have enough work yet, so we will improve the weapon of our protagonist. It didn't look quite, while the production, sorry, while the production design department did its best, it looked still somewhat plasticky when we looked at the final footage. So we decided to add a glowing energy orb to her gun, just to sell the sci-fi cyberpunk feel. And we also added, which you unfortunately can't see in this shot, a lot of laser shots from our main actor, or both the actors. We also had some classic blue screen shots, as mentioned, and this is one of these shots. How do you start this? The whole virtual production world was basically built in Unreal Engine, but for this shot we needed a new environment since this alley didn't exist in our Unreal world. So we decided to simply go for better quality and go for offline rendering, which in our case was done in Blender. And this also meant that we have to port some assets we created for Unreal Engine back into Blender. They were originally created in Blender, then put together in Unreal Engine, and now needed to be put back into Blender for offline rendering. This worked out great for this shot because there aren't too many assets, or weren't too many that were needed. But in this next shot, which is a full CG wide shot, it would have been too much work to port everything over. We tried with the USD, but didn't work out perfectly. So due to time constraints again, we decided to stay in Unreal Engine with this shot and instead try to max the render settings, basically meaning using Unreal's built-in path tracer. This was a curse and a blessing at the same time because it looked better than the real-time render engine, but unfortunately the path tracer still has some limitations. It's relatively new, I'd say. For example, a lack of render path support. We had some nasty rendering artifacts which we couldn't resolve and needed to be cleaned up in compositing, and lack of information and detail regarding issues such as the render artifacts. Coming to the conclusion of the set extension workshop, we're obviously, first of all, very grateful for everyone who made it possible for us to learn about virtual production and participate in this workshop. We all learned very much, especially regarding virtual production, since it's, I'd say you can still say it's a new technology, and you rarely get the opportunity to just play around with it and test things. Since it's quite expensive, so very big thank you to everyone who made it possible, as said. Yeah, and as last point, what we learned that you need a great team. This was our team. I think about everyone is in this picture that participated. We're grateful for everyone, and thank you for listening.
I think we have time for questions, and you can stay up front and have the TDs also up front. I don't know if you've mentioned it, but did you say that there was an intentional reference to the Blade Runner movies? No, you didn't, right? Did you say?
We didn't. Oh, now it's quite loud because I'm standing in front of the speaker. The original concept, since there was too much focus in the last years on creating a story, so this year we were given some orientation, such as a Blade Runner setting, and we could pick a location setting, and we chose the rooftops. We didn't mention the Blade Runner since we deviated, I think, a bit from Blade Runner and turned more towards cyberpunk. But originally, yes, Blade Runner setting was given as ace. Yes, as premise.
I have a question for Paul about the acid cooker. So I was curious about the execution part, because you have some kind of a scheduler for the job. So can you just elaborate a little bit about it, like how it can be configured? Like, can you run it like a render farm or anything like that? Yeah, just I'm curious about the details.
First of all, good question. I haven't mentioned what's actually happening in the background for all those different recipes. So in the case of the geometry conversion recipe, for example, I'm just using Blender and getting the stuff in and getting it out in the required format. For the polygon reduce recipe, I'm starting Houdini and doing the same thing and just dropping essentially the polygon reduce node. And for the sequence to video recipe, I'm using FFmpeg. So this is basically, it really depends what you want to do, and you would implement it yourself in the recipe. And the cooker at the moment, it doesn't run concurrently. It basically really only kind of works the queue one after another and executes each recipe's prepare, cook, and finalize function after another. So there are like these three functions. They contain your logic of the recipe, and they are just called one after another, essentially. But in theory, you could quite easily probably write your own cooker. There was also a previous idea, but I didn't manage to do it, that would maybe do some sort of farm batch processing or something like that. It's actually quite a simple class, so you could probably just write it yourself and do whatever you need to do.
All right, thanks.
No worries.